Okay, so question 1 of the test looked a bit like this. A package of weight 20 newtons is moving up an inclined plane under the action of a horizontal force of 30 newtons. The force is acting in a vertical plane through a line of greater slope of the plane. The coefficient of friction is mu. And the plane is inclined at an angle of alpha, where tan alpha is 5/12. Okay, so from that information that tan alpha is 5/12, let's quickly just draw a triangle and get that bit done. So alpha is there. Tan alpha by definition is opposite over adjacent. So it's 5, put the 5 as the opposite, and the adjacent is 12. Using Pythagoras, you can work out this as 13. Now you can read the sine alpha value of the triangle, so opposite over hypotenuse, and the cos alpha value as well, which is 12 adjacent over hypotenuse 13. So now when we use our sine alpha and cos alpha, we can just sub those values in. Next thing you want to do is we want to draw all our forces. So we've got a reaction force going perpendicular to the plane. We've also got it's moving up the plane, so we're going to have friction coming down the plane. And there's F, and it's got a weight of 20 newtons. So that's all my forces on my diagram. And then the question is asking, find the magnitude of the normal reaction. So those of you who I teach know that I like to do a table for this. So I list all my forces here and then resolve them all into their respective components. Because it's on a slope, we're going to do things in a parallel and perpendicular components. So we've got R doesn't have anything parallel. R only has a perpendicular component. F is going down the slope, so this is going to be minus F, and it doesn't have a perpendicular component. Now, because the 30 Newton force is horizontal, I need to resolve that. So I'm going to make a triangle. I'm just going to do that in red so we can see it there. So there's my perpendicular, and this is my parallel component for the 30 Newton force. The perpendicular will be going into the slope, and the parallel will be going along the slope. And this angle, because of Z angles, is alpha. So parallel to the slope, I've got 30 cos alpha, and perpendicular to the slope, I've got 30 sine alpha. So I'm just going to put those in. Parallel to the slope was 30 cos, and it was going along the line of up the slope, so I'm going to leave that as positive. And the perpendicular was going into the plane itself, so it's 30 sine alpha, but it's negative because it was going into the plane. With the 20 Newton, again, we have to do the same thing. So let's resolve it like so. And here you've got 20 cos alpha, and the one opposite, this is alpha, opposite the alpha is going to be 20 sine alpha. Let's put that in. So we've got minus 20 sine alpha here, and minus 20 cos alpha. Both of them are negative because if you look at the perpendicular one, it's going into the plane, whereas my arrow is going off the plane. And then the 20 sine alpha is going down the slope, and my arrow was going up the slope. Now, I was interested, the question's asking me to find R, so I'm going to look at the one that's perpendicular to the slope. So let's now, what we can do is just, so a lot of you would have skipped the table, which is completely fine, and just gone straight to these equations. I just like to do it just to split up the forces. Now we've got R plus 0 minus 30 sine alpha, but sine alpha was 5/13, so we can sub that in now. So it's 30 times 5/13 for the sine alpha, and then minus 20 cos alpha, and cos alpha was 12/13. And the particles don't bounce off the surface. So in the perpendicular plane, the resultant force, this is what you've calculated, the resultant force will equal to 0. And if you rearrange this equation, you'll get R as equal to 30 newtons. So that's your value of R found there.